Hi guys, I'm Sai Krishna. So let us look at the question number 10. In question number 10, the question says that we have to show if the normal process WS is, then it is SSS as well. That is strict sense stationary as well. So for this question, we basically want to prove that uh, fx of x1 comma x2 comma so on up to xn for time instances t1 comma t2 so on up to tn, that is equal to fx of x1 x2 so on up to tn for time instances t1 plus epsilon comma t2 plus epsilon so on up to tn plus epsilon. This is basically for any n, uh, and for any t, t1 t2 so on up to n, and for any epsilon. So given that x of t is normal, we know that fx of x1 comma x2 so on up to xn, for time instances t1 comma t2 comma so on up to tn can be written as 1 by root over 2 pi to the power of n, into root over determinant of c, into e to the power of minus half into x minus neta to the power of transpose into c inverse into x minus neta. So this is the formula basically. So here we are writing the value of c here. So basically c can be written as expected value of x minus neta into x minus neta transpose. So we are basically writing that in the determinant form here, which is e of x t1 minus expected value of x t1 so on up to x tn minus expected value of x tn into x t1 minus expected value of t1 so on up to x tn minus expected value of x tn. So we clearly know that expected value of xt1, xt and so on are basically neta. So we can change the we can rewrite the c as in autocorrelation as this one, r of t1 comma t2 minus neta square so on up to r of t1 comma tn minus neta square. This ranges so on up to r of t1 comma tn minus neta square till r of tn comma tn minus neta square. So this can be simplified as r of 0 minus neta square so on up to r of t1 minus tn minus neta square so on up to r of t1 minus tn minus neta square, or so on up to r of tn minus tn minus neta square. So we are basically preparing the matrix here. So the c can be simply written as c of t1 minus t2 comma so on tn minus 1 minus tn. So this can basically written as c of ti minus tj for any I not equal to j, and I comma j ranging from 1 can take any values from 1 comma 2 comma so on up to n. So let us look at this. So the density function, coming back to the density function, the density function can be rewritten as fx of x1 x2 so on up to xn for time for any time instance from t1 t2 so on up to tn is equal to fx of x1 x2 so on up to xn, taking time as ti minus tj for I not equal to j, and I comma j taking values from 1 to n. So fx of fx of x fx of x1 comma x2 so on up to xn, for time instance t1 plus epsilon comma t2 plus epsilon so on up to tn plus epsilon can be rewritten as density function of x1 comma x2 comma so on up to xn, for time instances ti plus epsilon minus tj plus epsilon, where I is not equal to j and I comma j can take any values from 1 comma 2 comma so on up to n. So this can be rewritten as density function of x x1 comma x2 so on up to xn semicolon ti minus tj I not equal to j, I comma j equal to 1 comma 2 comma so on up to n. So this can be simply written as density function of x, x1 comma x2 so on up to xn for time instances t1 comma t2 comma so on up to tn. So basically in this way I've proved that if the normal process WSS, then it is SSS as well. Thank you.